Hey, Belk. Sup? You know what? I can't wait for June the 1st. Why? Because I'm about to get my sine over cosine on. Your what? Sine over cosine. Oh. Thought that might be funny for y'all today. Intro to double angle identities, everybody. I know you're excited. Remember, you can pause this video at any time and write down all the identities first before we start doing the examples. So here are double angle identities. We've done sum and difference identities. We've done Pythagorean identities, fun identities. Okay, so here are the sine, cosine, and tangent double angle identities. So if you have the sine of 2 theta, something like the sine of 120 degrees, well, you could actually write that as 2 sine of 60 cosine 60. This would be a double angle here. Or if you had cosine of 90 degrees, that's the same as cosine squared of 45 minus sine squared of 45. There's actually 3 for cosine, as you can see right here. There's cosine squared minus sine squared, not to be confused with my favorite identity, which is if you were a sine and I was a cosine, together when you add them, they make 1. No, this is cosine squared minus sine squared makes a cosine 2 theta. And then 2 cosine squared theta minus 1, and then 1 minus 2 sine squared theta. And then our last one, tangent 2 theta is equal to 2 tan theta over 1 minus tan squared theta. So the first thing we're going to do is rewrite some of these as a single trig function, okay? So if I have 2 sine 40 cosine 40, I actually can rewrite this as one single trig function. 2 sine cosine, 2 sine cosine is the same as sine of 2 theta. So if this is theta, you just double it. Here's theta, just double that. It would be sine of 80 degrees. Okay, cosine squared minus sine squared. Well, that's a cosine identity. So we're going to write cosine of what? Here's my theta. Just double it. 70. 1 minus 2 sine squared. 1 minus 2 sine squared. That's another cosine one. 1 minus 2 sine squared. So just double your theta. Here's my theta. It's a cosine of 120 doubled is 240. All right, and last but not least, 2 tan pi over 6 divided by 1 minus tan squared pi over 6. Again, this would be your theta. It's a tan. So you would write it as tan of pi over 6 doubled. So pi over 6 doubled would be pi over 6 times 2, which would just be pi over 3. Very easy. Now let's actually do a little bit more trickier problem, one like you're going to do homework tonight. You're going to be asked to find the exact value of sine 2x, cosine 2x, tan 2x. Those are all doubles, given that cosine x is 1/4 and 270 is less than x is less than 360. Sounds like a lot. I don't want you to think this is as easy as it sounds, but it's not too difficult, okay? First of all, let me explain what this is. This is telling you really what quadrant they want you to be in. What quadrant am I in if I'm from 270 to 360? I'm in quadrant 4. Okay? We were given the cosine of x is 1/4. So you're probably thinking, oh, can I just double 1/4? No. Here you're doubling the angle. You don't double the ratio. This, you don't just say, oh, 1/4 times 1/4, oh, double it is 1/8. No. Or 1/2. No. 1/16. No. Okay? You have to do actual work using the identities. So let's just go over what cosine of x equals 1/4 means again. Cosine is your what over your what? your adjacent over your hypotenuse. Adjacent over hypotenuse. So guess what we're going to have to do first? That's right. We're going to have to draw it. Draw it. Always, always, always go back to drawing. It helps you out. And we know we're in quadrant 4, so let's draw this in quadrant 4. Here's my right angle. Here's theta. Or x, actually, since we're talking about x. But I put theta. So if I'm standing here, my cosine is my adjacent over hypotenuse. So this would be 1. This would be 4. How do I figure out this side? Good old Pythagorean theorem. 1 squared plus, we'll call it x squared equals 4 squared. So x squared equals 15. So it's the square root of 15. Be careful though. Is it positive or negative if I'm in that 4th quadrant? I'm down, so it's negative. 1 is positive, but down there you're negative, okay? Once you draw it and then label the parts of your right triangle, then step 2 on tonight's homework is you are going to find regular sine x, regular cosine x, and regular tan x, okay? We're not going to do these just yet. We're going to find, just like we did way back in last chapter, sine x, cosine x, tan x, okay? So let's see, what's the sine of x, or theta? I guess I called it theta, but you know what I mean. Sine x is opposite over hypotenuse, so negative root 15 over 4. Cosine x is, well, we already knew that, 1/4. And then tan x is opposite over adjacent, so just negative root 15. Cool. Then step number 3, you use your identities to solve for sine 2x, cosine 2x, and tan 2x. Sine 2x, cosine 2x. So use those identities to solve. We'll start with sine. Sine of 2x, let's go back to what the identity chart said. Sine of 2 theta is 2 sine x cosine x. So 2 sine x cosine x. Okay? Well, look at what I got here. I know what sine x is. That's right there. That's what sine x is. And I already know what cosine x is. That's right there. It's 1/4. Sine x is negative root 15 over 4. And then 2 stays out in front. So now, multiply cross, or if you can cross cancel, do so. You can actually cross cancel that part right there, and then multiply cross. So this would be negative root 15 over 2 times 4, which is 8. This is the exact value of sine of 2x given cosine x was 1/4. We didn't even need to know what the angle was. That was the exact value. All right, let's do it for cosine. Let's find cosine 2x now. So again, you have a choice. You can use whichever one of these you want. I just like using the first one, but it doesn't really matter. So I'm going to use the cosine squared x minus sine squared x. And again, cosine squared x means you square whatever cosine x is. Cosine x is 1/4, so it's 1/4 squared minus, find your sine x, negative root 15 over 4, and square that. 1/4 squared is 1/16. And the negative squared right here is going to become positive. Square root of 15 squared is just 15. 4 squared is 16. What's 1/16 minus 15/16? That would be negative 14/16, which is equivalent to negative 7 over 8. So the exact value of cosine 2x, look at that. It wasn't 1/2, it wasn't 1/8, it wasn't 1/16. You don't just double it. You actually have to use the property. It's negative sin eighths. All right, and then my last one, let's find tan of 2x. So tan of 2x, the formula, again, look in your notes, is 2 tan x over 1 minus tan squared x. Okay, so let's look at negative square root of 15. So this would be 2 times tan of x is negative square root 15 over 1 minus tan x squared. So negative square root of 15 squared. So let's see what this simplifies to be. 2 times the negative square root of 15. You cannot multiply these together. This is on the outside. This is on the inside. So it just remains negative 2 square root of 15 over. The bottom will be 1 minus, and again, here we have that negative squared is going to be positive. Square root of 15 squared is just comes right out. So 1 minus 15, which is negative 2 root 15 over negative 14. Those can reduce. And your final answer would be a positive root 15 over 7 in exact form. So again, steps. Draw it. Label your sides. Then find regular sine x, regular cosine x, regular tangent x. They're not going to tell you to do these 2 steps, but you need to. Then use your identities to solve. Okay, use all those identities that we just showed you on the first step. Enjoy, everybody. Email us if you have questions, and then try your homework tonight. Thank you. Bye-bye.